everyone. My name is Darius Swift.
Brandon Hines.
Aiden Winkler, and today we'll be going over a database credential packet sniffing demonstration. To begin this demonstration, we hosted an unencrypted MySQL database running on an Ubuntu desktop virtual machine. We utilized the command line and SQL queries to list the database name, the database tables, and the database users as shown.
Here we have a mock login page running on an Apache web server that is linked to the database. We are first going to try to generate unencrypted traffic by logging in with each user. This traffic is unencrypted due to the web server running HTTP.
We are logging in with each user and have been met with a login successful after each one. But for the test one, we purposely used invalid credentials to show that this would then be captured on Wireshark's end.
Now we're in Wireshark. Highlighted on the bottom, we have plain text credentials used for each login attempt. These are captured in an HTTP post packet over the network. And clearly, this exposes the credentials to the network.
Using a feature on Wireshark, you can listen to a specific port, and the default listening port for a MySQL server is port 3306. We can see within the TCP packet stream that a Brandon H user was trying to access the database, and this was in plain text because of no encryption.
Now we are on the second Ubuntu virtual machine. This will be our encrypted setup. Here we are going to highlight a segment capturing the need for security on both front-end and back-end communication. We are utilizing MySQL Workbench, which is a graphical user interface. Here we are showing the database name, table name, and the users in the table. Now we are logging into the root account and showing that SSL is enabled. We will also start a test connection. From this successful test connection, you can see the encryption algorithm in use. Going back to Wireshark, we will filter by port 3306 and see the encrypted data being sent through the network. The following packets show the client and server recognition and certificate exchanges. Additionally, the user entry is encrypted as well. Now let's switch to the login page accessed by a user on the same network. We are showing the web client connected by HTTP. Here's the issue that is faced with interconnected systems. The Apache server has yet to be configured with SSL encryption. Using valid credentials, we'll simulate 2 login attempts. Now we go back to Wireshark once again and filter by port 3306. The data exchange clearly shows TLS encryption as well as certificate exchanges. But the front-end web server accessible to users is not configured to use SSL encryption, showing a clear flaw. The HTTP traffic captured on Wireshark shows plain text credentials.
After configuring the Apache server to run through encryption communication, we use the web client to run the server through HTTPS, which is shown here.
Additionally, we'll be simulating 2 successful logins again.
Now we go back to Wireshark and filter by port 443, which is the standard port for HTTPS secured communication. This will show that the web server is now encrypted by TLS. The credentials of the users are not able to be seen on the same network.
This demonstration covered several aspects of encryption and database security, while also highlighting weaknesses regarding interconnected systems.
Thank you, and we hope you enjoyed our demonstration.